All right, good morning. It's 8 o'clock, so we'll go ahead and get started. Just a reminder that the session is being recorded, and I will get it posted up later today on the course announcements. So if you need to go back and review it, it'll be there. So I'll start off by saying I think this week's material is probably the most important material for the entire class and really for programming in general. All programming is kind of built upon what we're going to talk about in today's class. So this week's material is all about functions. So, what is a function? A function just means it's really just a piece of code. Now, it could be some code that somebody else created, somebody else wrote, or you can make your own functions yourself. But as we give demos in class, you'll see the importance and the power of functions. But a function, you can just think of it as a piece of code that is ran, and it takes inputs and it will give to you an output. The inputs to the function we call the arguments. We also can call them parameters. I will use the words arguments and parameters kind of interchangeably. And your function will also return back to you a value, and we just call that the return value. And a lot of times what functions are useful for is doing some kind of computation and then telling you what the answer is. And the example that we do here in a little bit, we'll do exactly that. So let's start off with talking about some built-in functions. So Python has a lot of built-in functions that are inherent to Python itself, meaning the people who created Python, they actually provide a lot of built-in functions automatically. And you've actually been using them over the past few weeks. So let's see what some of those look like. So actually, the one I just had up there, the print is actually a function. So here's what a function looks like when we call the function. Now, whenever I say call a function, that means we're telling the computer to do the code associated with that function. So for example, we have print, right? Print, and then inside of here, we can tell it what we want to print. This print is a built-in Python function, meaning somebody else somewhere wrote some code to actually show the letters on your screen. Whenever it displays the result in your console, let's save it and run it. So all the work that went on behind the scenes to actually print that out to your screen was done inside of a function. Now, we don't see that function here, but what we're doing is we're calling that function. The name of the function is print. And then we have these braces right here. Parentheses. We have the open parentheses and the closed parentheses. And inside the parentheses, we have what are the arguments to the function. Like I said, you can also call them parameters. I'll use the two words interchangeably. But this is the parameters that we're giving to the function. Now, a function can take more than one parameter. There's no rule to how many parameters a function should take. But the people who created the actual print function that does the actual work, they are the ones that determined, well, I need you to give me one parameter, and the parameter I want you to give me is the string that you want to be printed out to the screen. So this is one example of a built-in function. Like I said, the function name is print. Then you have the open and closed parentheses. Inside of the parentheses, you have all of the parameters that function requires. And for print, it only requires one parameter, and that's the string you want to print out. Let's look at another function that you've been using regularly is input, right? This is what your input looks like, right? You've been using input over the past few weeks. This input is also another built-in function. The name of the function is input. And then you can see we still have those open and closed parentheses. Inside of the parentheses is the parameters that the input function is expecting you to give it. And for input, this string is just what it prints to the screen as the prompt for your input, right? Now, these do look a little bit different here, right? Here we're having A is equal to this input function. We didn't do that for the print, but we are doing it for the input. And why is that? Well, it's what I said at the very beginning is each function, it takes an input and it returns to you an output, right? However, the print function doesn't actually return you anything because if you think about it logically, what would print return to you anyway? What would you expect print to return to you? What answer do you think print is going to give you? And the thing is that there isn't anything. So print does not return any kind of answer, or it does not return any kind of value back to you. So that's why I don't have a variable equals print. I don't do that because print doesn't actually return anything. However, input does. Input, the built-in function input, it takes this as a parameter and it returns to you whatever the user typed in at the keyboard, right? And so whatever they type in at the keyboard is in that A variable. And just to confirm it, stuff we've already been doing. So we're going to call the print function and do that. We're going to call the input function with that parameter. It's going to return to us whatever was typed in at the keyboard. And I'm saving that in my A variable. And then I'm just going to print the A variable. It should be short. There's hello world, type in something, and then it prints the something. So these are a few examples of built-in function. Now, the function itself actually has a lot of code inside of it, but it's kind of hidden from you here because it's a built-in function. And so it's not something you had to create yourself. In a little bit, we're going to create our own functions and you'll kind of see the work that goes into it. But right now that's kind of hidden from you because these functions already exist and we're just using them. We're calling the function, and calling the function is what we name it whenever you actually use the function. All right, let's just do a couple more of the built-in functions. So far we've done the print, we've done the input. There's also one called, there are many built-in functions, but we'll do a few of them. There's one called min, and what it'll do, it'll return to you the smaller of two numbers. So the min function, for the input, it's expecting two numbers. So let's say 5 and 6. And if you notice here, I kind of put a comma in between them. So for the print, whenever we do a print, it only wants one input. It wants one parameter, which is what we want it to print. But for min, it's expecting two parameters. It's expecting you to give it two values. And so you separate those values with a comma. So I'm telling min the first parameter is a 5 and the second parameter is a 6. And so what min will do, it will take this input and it will return to you the smaller of the two values. And then we're just going to print that out. And just like with min, there's one called max. And it will return to us the larger of two values. So if I run those, we should get a 5 because 5 is the smaller number. And we should get a 10 because 10 is the bigger number. And there we go. We get the 5 and the 10. So those are just two more really short built-in functions. And we'll do one more, and then we'll move on. The last built-in one I want to show you is called LEN, and inside of here you can put a string, something, right? What this LEN does, it stands for length. It'll tell you how many characters are in your string. So let's make this shorter. ASDF, there we go. So length, it takes one input parameter. The one input parameter is a string, and it will return to you how many characters are in that string. That's how the LEN function works. So let's run this, and it should tell us 4, because 4 is how many letters are there. And it does. Tells us it's 4. Of course, if we make it longer, it tells us how many characters are in it. That should be 8. And it does. It tells us it's 8. So those are a few of the built-in functions. There are a few math ones that I want to mention. So just like this print and this LEN, they're kind of built-in functions to Python, which means the creators of Python made the code to made the actual print function, and they made the length function, and we're just using them. There's some math ones that are, they're not exactly built in, but you can think of it about code that somebody else wrote, but we're just going to use it. And so if we want to use some of these math functions, the first thing we have to do is say import math. Now what that does is it's a math library. And what I mean by library, I just mean it's a bunch of other code that somebody else wrote. You know, who wrote it, it's not important for us here, but we just know that there's a whole bunch of math functions that somebody else wrote. And if we want to use those math functions, we have to say import math. And that's telling Python there's a math library, and I want to use the functions that are inside of it. That's what the import math does. So now we can use a lot of these math functions. The first one that we'll talk about is there's a math.sqrt. SQRT gets the square root. And if you see, I kind of call it like this. I say what library it's in. So it's math. It's in the math library. And then I put a dot, and then I put the name of the function I want to use. The name of the function I want to use is SQRT, stands for square root. So I'm telling this function, this square root function, this is the input to the function. The input is 49, and the square root will return to me the square root of that number. So let's print S. Oops. That should give us the answer 7. Save it and run it. And there we go. We get the answer 7. It's 7.0 because it treats it like a floating point number. But the answer 7. You know, if we put 121 here, that should give us 11 for the answer. There it is, 11.0 for the answer. So that's one of the math functions we can use, square root. There's some other. You can have, just like with all your trigonometry stuff, you can do a cosine. Actually, what we'll do is do a print math.cosine of 1. We print math.sine of 1. Oops. And print math.tangent of 1. So those are some of your math trigonometry functions. Let's just run that and see what happens. There we go. There's all of those math answers for each of those things. So fortunately, you know, we don't have to figure out how to compute a cosine or a sine or a tangent. We don't have to figure out how to compute a square root. Somebody's already done those functions for us. And so now we're just using them out of this math library. And last one I'll do is we do math dot POW, which is you know, like exponents, right? So we can say 2 raised to the 4th power. I think that's like 16. If we run it, yeah, there we go. The answer is 16. All right. So we could do like 4 to the 3rd power. Or that is 1664 or something. Yep, there's the answer, 64. 64 is 4 to the 3rd power. So here's how you can do a lot of these kind of math functions. If you're computing some kind of math equation, you can use this math library to do some of the computations for you, such as sines and cosines and powers and square roots and things like that. There are a lot of other functions in this math library. And so how do you know what they are? Well, what you do is go to Google, you type in Python math. You know, one of the first few links you can kind of see here, you know, this mathematical functions documentation, or this one right here is pretty good too. If we go to here, you know, it tells us all of the math functions. There's a math.sil, and it tells you what it does. It tells you what it takes this input, it returns whatever output. You know, we can scroll down to is finite x, you know, whatever you want to look at. But there are tons and tons of these math functions that you can use. You know, there's some exponent functions, some log functions, and so on and so forth. So you don't necessarily have to remember every single math function that there is. That's kind of, you know, not really possible to memorize every single function. But looking at documentation is also important to be able to do. So if you want to do some math, the thing you have to remember, you know, is import math. And then you can do some searching through some documentation to find the exact function that you want to use. Right. So that's all about kind of the built-in functions. So now we're going to make our own function. Like I said, this math library contains a lot of functions that somebody else created. We don't really need to know who created it. It's not that important. But somebody else made the functions, and then we are just using them, right? So what we're going to do now is we are going to create our own function that we want to use. And the example I'm going to use is we are going to compute the area of a rectangle. Okay. So first we'll do it without a function, and then we'll do it with a function. Okay. So how do we compute the area of a rectangle? Well, let's get input from the user first. We'll have the user put in the length. That's the user for the length. And then we'll have the user type in the width. And how do we compute area? Area is just length times width, right? And now we will print the area. So this is without a function. This is just getting the length from the user, getting the width from the user. We're going to compute the area, and then we're going to print the area. So let's run that without a function. It's asking for the length. We'll say the length is 3, the width is 4, and it tells us the answer is 12, and that's right. Okay, so how do we do this with a function? Well, generally your functions should be at the top of your file before the rest of your code gets ran. And here's how we make our own function. It starts with the letters DEF. DEF stands for define. It's just saying we're going to define a new function. Then we put the name of the function. And the name of the function can be anything that we want it to be. Just like how we can name a variable anything we want it to be, we can name a function whatever we want it to be. Now, it is important that you name it something descriptive that kind of describes what it's actually doing. So for us, I want to say it's compute area. Compute area of rectangle. That's the name of my function. The name of my function is compute area of rectangle. That's very descriptive about what it does. Now we need to tell it what are the inputs that we expect. What are the parameters to the function? We do that inside of these parentheses. We have an open parentheses and a closed parentheses. And inside here, we put the parameters that we're expecting. And so to compute the area, we need the length and the width, right? So we're just going to say L comma W. L will be the length and W will be the width. Now we put a colon. This is just the way Python functions are done. So we have the DEF for define, we have the function name, we have the open and closed parentheses, and then inside of here, these are the parameters that we expect to receive. We expect somebody to give us the length, and we expect somebody to give us the width. Then we have the colon, and after the colon, we have to tab over a space, just like we did with the if statements last week. You know, when we did if something colon, you tab over and all of the code that's tabbed over gets executed. It's the same way for a function. Is after you put this colon here, the rest of the code that is tabbed over is what is part of that function. So if I do all this stuff here, if this was actual code, it would execute all of that code as part of the function. However, if it gets here and it's no longer tabbed in, that means this is not part of the function. Only the tabbed in parts are part of the function. Okay, so let's do the work now. Now we have to do the work of what the function is supposed to do. So if the function is supposed to compute the area of a rectangle and L and W are the length and the width, the area will equal the length times the width, right? And then we need to return, if I can spell it right, we need to return that area. And that's all there is to this specific function. One more time, DEF, define a new function. This is the name of the function. These are the parameters, meaning L and W. Here, I'm doing the work of the function. So I'm actually computing the area. And then when I'm done, I want to return this area I have computed. So now let's use our function. So we're still going to get the length from the user. We're still going to get the width from the user. But now the area is going to be my function, compute area of a rectangle, that length and the width. And then we're going to print the area. So what's going to happen here is whenever you run the program, you know, generally it starts at the top of the file and works its way down. Well, the same thing will happen is when your Python program starts executing, the first thing it's going to see is this, but Python is going to recognize this as a function. So this code does not automatically get executed whenever you start your program. The code for a function only gets executed whenever you call the function right here. So Python recognizes this as a function, so it kind of skips over it. And this is actually where your execution starts. So the first thing it'll do is ask for the length and you type it in. Then it'll ask for the width and you type it in. And then you are calling this function compute area of rectangle. So whenever you call this function, Python then skips up here to the function itself and starts executing this code. After you do the return, the execution comes back down to where you called it from, here. So this is where it will resume to after you do the return. Oops. And so since my compute area, it returns a value, it returns this A, and this A is the computed value. So computed area of rectangle returns something. And so I'm saying this variable is equal to whatever it returns. And then I'm going to print it out. If we see, it's the same thing is going to happen. So save it and let's run it. Put the same inputs and we get the same answer of 12. Now this part is extremely important to remember. So inside of a function, we're using these different variables, right? We're using this A, we're using this L, and we're using this W. It is extremely important that inside of a function, do not use any variable that exists outside of the function. Do not use any variable unless it's one of these input ones. Now you say, what about the A? And the A is fine because when I say A equals, that's creating a new variable, and that's fine. But for existing variables, you only want to use what is right here as input. And what do I mean by that? What I mean is do not use the length variable. So do not do this. Okay? Because length and width, they exist outside of the function. You know, this right here, that is the entirety of the function. That's all there is to it. And so this length and the width exist outside of the function, right? Here is where they exist, outside of the function. So do not use those variables inside your function. Now, they kind of get copied over to your function. And where does that happen at? Let's change this back to the L and the W so we don't get confused. So when we call our function, we are giving it the length and the width, but we're not giving it the variable. We're giving it the value that it represents. So whenever I type in the number 4, that means length is equal to 4, right? Length is the value 4. And so whenever I call the function and I give it the length, the variable is not what goes to the function, it's the value it represents. So this is just saying the value 4 and the value 3. It, you know, if I type in 4, if I type in 3, then it's giving the function the value 4 and the value 3. So then whenever I call the function and it comes up here, this L, it will be equal to that 4. And the W will be equal to that 3. Whatever those values are that I gave it as an input parameter. Let's do another example. Let's say compute area of circle. And for the area of circle, it's pi r squared, right? So make a comment here. The area equals pi times r squared, squared. All right, that's the formula for a circle, right? So to compute the area of the circle, what piece of information do we need to know? Well, pi, that's an automatic value. We don't need pi as an input here because pi is a fixed value. R, well, R can be anything, right? That's the radius of the circle. That can really be anything. So we do need the radius as an input. Oops. And we don't need squared because that's just saying R times R. So now let's compute the area of a circle. It's A is equal to pi, which, pi is 3.14159 and a bunch of other numbers. That's pi times R, and squared is just R times R, right? We could do that, or we could go back to our import math, and R squared is math.pow R2, right? Remember, the math.pow function does this power, it does R to the second power. So this is pi times R squared, and then we're going to return that area. So now down here, we're not dealing with lengths and heights anymore. We're dealing with a radius. There's no width. Well, let's leave the width there for a second, and I'm going to show you a problem so that we can avoid the problem in the future. Okay, so we're getting the radius as input. Then we're going to have them type in a width, but because we made an error, and I want to show you what the error looks like so you can avoid it. And then we're going to say the area is equal to the compute area of a circle. Well, the first thing it wants is the radius, and then we'll still give it the width. Like I said, this is an error, but I want to show you the error. All right, so save it, and let's run it and see what happens. Enter the radius of, say, 1, width of 3, and it gives me an error. And it's telling you this function takes one argument, but 2 were given. So the problem we made was our function here, it only wanted one input. It wanted an R. But we tried to give it 2 inputs. And so it breaks Python because I said to give my function 1 input, but you're trying to give it 2 inputs, and that's wrong. And so we go back and look at it. Oh, there is no width. We're only supposed to give the radius. So we fix that and take it away. Now we can save it and run it. Say radius of 1, and there it gives the answer. With the radius of 1, that's the area. With a radius of 123, that's the area. So that computes it okay. So that is how we make our own function. Define, name a function, all the input parameters that we want. Then we start tabbing over our code. We do whatever computation that we want to do. In here, it's just a simple computation, but as much code as you want to compute whatever you need. And then at the end, we return the answer. And so here, we're going to call the function. We're going to give it that value, that parameter it wants, and then it will return to us whatever the answer is. Okay, that's how you make your own function. And they can be certainly more complicated than this. This is just a short, small example. But it can be as complicated as you want. It can do as much computation as you want. That's fine. What you want to avoid, though, is generally there is no input or output, meaning no input from the keyboard and no print statements. Generally, there will not be those inside of your functions. all of your input and output should really be out here in the main part of your code. Okay. The functions itself should really only be to do some kind of computation. There are exceptions, and there are a few reasons why you would do some kind of input or output, but those are generally not the case. And certainly for this class, I don't think there's any good cases for putting input or output inside of your function. So if if you get a question that says, create a function to have the user, or, let me start over, have the user input a value, use a function to compute the area, and then print the answer. So I use the words, have the user input, make a function to compute the area, and then print the answer. Well, none of that input or print was actually in my function, right? Here in my main part of the code, I got the input. There is where I did my function. And here is where I print the output. So generally, input or output does not belong in a function. Okay, talked about that. Talked about the parameters. We talked about the return values. All right, so this is the main point, the main gist of what this week's material is all about these functions, about being able to create your own functions, recognizing the input parameters, and recognizing the return value from those functions. So what I want to touch on is a little bit of your assignment. And then after we touch on the assignment, of course, I'll open it up so you guys can ask whatever questions you want to ask. So let's delete this all off here. Let's look at your assignment. So your assignment is really just kind of modifying what you did last week for your last assignment. So for your last assignment, what you were doing is, you were having the user type in how many rooms they had in their house and what kind of cleaning that they wanted to do. And based on that, you did a computation to determine how much you're going to charge them to clean their house, right? And you did all of that just straight code in a row, no functions involved, right? Well, now this week, there is a function involved. You need to make your own function. And what your function needs to do, it needs to compute the cost that you're going to charge. So still in the main part of your function, you're still going to have the user input, how many rooms are in your house, and you're going to have the user input, what kind of cleaning do you want? Okay. Once you get that input from your user, you want to call a function to compute the price. It should return and it should also return what that price is, what the cost of cleaning is. And then you're going to display that cost to the user, right? So something like this, make function to compute price with number of rooms and type of cleaning inputs. All right, that's probably the first thing you got to do. Then you're going to have to input from user number of rooms. Then you're going to have to input from user type of cleaning. Then you need to call your compute function, which is, what you're doing right up here. And then you're going to print out return price from compute function. That's kind of how your assignment is going to break down. Okay. Let's do an example, not of your homework assignment, but let's do a little bit of an example that's somewhat like it. So let's do some movie tickets. Actually, for the example last week, I think I did movie tickets. So let's do that example again, except we're going to use a function this time. So the first thing we'll do is So the cost of a movie ticket is dependent on how old you are and if it's 2D or 3D. So let's make a comment here. Movie ticket is based on age and if 2D or 3D movie. That's how we compute the cost of a movie ticket. So the first thing we need to do is we need to get their age, because the cost of the ticket depends on the age, right? So let's get the age. Enter your age. We also need to get if it's a 2D or 3D movie, right? So let's just call it type of movie is 2D or 3D, right? What we'll have them type in. So now here is where we need to compute the cost. Right now, we're just going to say the cost is 0. It's just a placeholder for a second. And then print the cost. So here we will just print the cost, right? So if we save this and run this, right now, yes, it's just going to print out 0, but let's just test what we have so far. To run it, enter your age, 33, 2D or 3D. Let's say it's a 2D movie, and there. Right now, the cost is 0. And that's just because we haven't done the computation yet, right? But what we need to do, we need to define a new function to compute that price. So up here, let's define a new function called compute ticket price. Now, what input does our function need to be able to calculate the price? Right here, we said the ticket is based on the age and if it's 2D or 3D. So let's say it's based on age and the type, right? That's what the A and T is going to be. The A is going to be the age and the T is going to be the type. So let's just say the cost starts out to be 0 and it's initially age based. So we're going to say if your age is less than, say, 10, you're a kid, and the cost is $5. If your age is less than, say, 65, and you're just the normal adult ticket price, so we'll say it's $10. Else, the cost will be $3. So what's happening here? These are really just else if statements that you kind of did last week. So we're just going to say the cost starts out to be 0. Oops, I'm using age. I actually did a big no-no. Age exists outside of this function. We want to use these variables. So instead of age, it's actually A. Oh, there we go. All right, so there we go. So we're saying the cost starts out to be 0. We're saying if their A, which is their age, if their age is less than 10, they're a kid and we're going to charge them $5. Or if they're less than 65, that means, they're just an adult age and they cost $10. And then, else, meaning they're 65 or older, then they're a senior citizen and they get $3. But it's also going to be based on the type. So if the type is equal to 3D, so if it's a 3D movie, we're going to add $5 more onto it. There's an extra charge if it's a 3D movie. All right. So let's think, have we computed the cost correctly? According to our own rules, we're making up the rules for how much the cost is, but let's make sure it makes sense. So I give, in this compute ticket price function, A is going to be their age and T is the type of movie, either 2D or 3D. The cost is initially $0 because we haven't computed it yet. And so if they are a kid, the cost is $5. Else, if they're an adult, the cost is $10. Else, meaning they're not a kid and they're not an adult, so they must be a senior. The cost is $3. And then after that initial base cost, we're going to say, well, if the type of movie is a 3D movie, then we're going to add $5 more onto it. And then at the end, we need to return that cost. And that's our function. So define, name a function, the parameters, do all the computation that you want to do, and then return the answer. So now in the main part of my program, I'm getting their age, I'm getting the type of movie. So now this cost is going to be the compute ticket price with their age and the type of movie. And then we're going to print the cost. Let's save it and run it. So let's think about what the answer should be. And this is where your test reports come in, of course. So if I'm 5 years old and I'm watching a 2D movie, how much should it cost? Well, if I'm 5 years old, then the base cost is 5. I said a 2D movie, so this does not apply. So it should be $5 if I'm 5 years old. If I put in 5, it's a 2D movie, and there's $5. Likewise, if I put in 7, a 2D movie, it's still $5, right? But if I put in, I'm 7 years old and say 3D movie, it's going to charge me 10. And is that right? Well, I said, what does it say? 7 years old, so it's there. And then I put a 3D movie, so I added $5 more, and indeed it is $10. And that's the answer. So that's how we get the cost, is we call the function, we give it the parameters that it wants, which is the age and the type of movie. It returns to us the computed value, and then we're printing that computed value. So this is extremely similar to what your assignment is this week, which, like I said, it's just a modification of last week's assignment to where instead of computing the answer right there in the main part of your program, you make a function to compute the cost of cleaning their house. And then you will have to make that function to compute the cost of cleaning the house. And again, these input variables you use should be the ones you're using as part of your computation. For example, I had a typo when I first did it. I put age here. If you use variables that exist outside of your function, you're going to end up losing points, because that's just a big no-no. Your program, if I left it as age, this program would actually execute, and this simple program, it would still give me the right answer, but the programming part of it has been done wrong. It only gives you the correct answer by coincidence, to be honest, whenever you use a variable that's outside the function. So that's why the variables should be only what you give it as parameters. Now, it's okay if you make new ones. Whenever you say a variable equals whatever, that's actually making a new variable, and that's okay. That's okay. But whenever you're just using a variable without making it as a new one, that's when you can only use your input ones. Okay, so that covers the material for this week and your assignment. And as I said in the beginning, functions are, to me, probably the most important part of this class to be able to grasp the concept, because the rest of the course is built directly on to being able to use and create your own functions. So that's all the material I have to cover. So I'll go ahead and open it up for any questions you may have. All right, you're welcome. I'll stay on for about 1 more minute to see if anybody pops up with a question. If not, I'll end the session. Go ahead and feel free to drop off whenever you want. And as I said, I will get this uploaded here in the next couple hours and get the link to it put in the course announcements so you can go back and review it for anything you may have missed. All right, looks like that's it. Everyone have a good weekend.